Okay, so in a previous recording, we looked at figuring out these positive oxidation numbers. And these multiple oxidation numbers for sure are in these transition metals in the middle. And to review what you've learned previously, I hope, is these group 1 elements are always positive 1, group 2 positive 3, group 3 positive 3. Then in the middle here, different charges. Then once we get over here, -2, -1, and we don't write any compounds with group 18. They don't want to do anything with their electrons. They're perfectly happy. So we will not see compounds such as helium nitrate or helium nitride or neon phosphate or argon or anything like that. Okay, let's now work on page 3. I want to remind you on page 1, anything you have on page 1, there is no parentheses. You first saw parentheses in the compounds at number 15. And 16, and 17, and 18, we saw some parentheses. So that's what we're going to do now, is we're going to write formulas of compounds that contain polyatomic ions. What are polyatomic ions? A group of covalently bonded atoms that have an overall charge. Okay, now I put number 1 on here. Just, you can sound this out. Some of these names sound kind of difficult, but this is not difficult. Here's my hexa, here's my cyano, and there is ferrate, and that's Roman numeral 2. And that's kind of a freakish one. So let's write this out. So sodium, Na, plus 1. If we look up hexacyanoferrate on our pink sheet, hexacyanoferrate right here, hexacyanoferrate 2, there's also hexacyanoferrate 3, but look at the Roman numeral. This is a weird one. It's negative. And what it's actually doing is telling us what the charge is of iron. This one has a positive 2 iron. This one has a positive 3 iron within that. So we have a positive sodium. We have an Fe, left parenthesis, Cn, right parenthesis 6. And that is a -4. Okay, to get 0 across the top, we're doing the same thing we did in the beginning. This should be, we're going to need 4 NAs, right? I could write 3 more to the left of this, but I'm not going to do that. If I write 3 more to the left, that'll give me a +3 plus this original one +4. So we know this is just Na4, Fe, left parenthesis, Cn, right parenthesis 6, for sodium hexacyanoferrate 2. Okay, number 2 is carbon dioxide. You see that it has the asterisk. This is a covalently bonded compound, 2 nonmetals. So if you see dioxide, you will not see it on your pink sheet. Carbon is C, oxide is O, and the di is 2. So I have mixed some of these in, some of these covalent compounds, and I think they still have an asterisk. Okay, let's do number 3. So number 3, we have calcium, which is Ca, positive 2. We have sulfate, SO4, which is -2. So we are done. We have 0 across the top, right? Calcium sulfate. Okay. +2, -2. We have calcium sulfate. Now, magnesium chlorite. Magnesium is Mg +2 chlorite. We look it up on our pink sheet. We have ClO2 -1. Chlorite or chlorite? Yep. Chlorite. There's chlorate up here. It's just clarifying. Chlorite. ClO2 -1. So ClO2 minus 1. Well, we don't have 0 across the top, so we know we need another chlorite, so we're going to write that in. ClO2 minus 1. Now I have 0 across the top. This would be written correctly. I guess we could leave it like that, but a shorter way to do that is to put the chlorite in parentheses. Just like we expanded these out in a previous recording, now we're looking at this and we're going to backtrack and use parentheses, similar to this. So, how many chlorides do we have? We have 2. So we're going to do Mg, left parenthesis, ClO2, right parenthesis, 2. Now, don't get parenthesis happy. Pretty soon I see some craziness. Pretty soon A in parentheses and Cl in parentheses. That doesn't do us any good. Water becomes, I don't know, something like this. We only need parentheses if we have more than one polyatomic ion like this. This is a polyatomic ion, a group of covalently bonded atoms with an overall charge. Here we only needed one sulfate. We don't do parentheses. So please don't go gonzo on parentheses. Let's do number 5. Mercury, Hg, plus 2. Oxide is O, negative 2, so that is done. Now, number 6. Iron 3 hydroxide. Iron plus 3 hydroxide. You can look that up on your pink sheet. We are going to have OH minus 1, OH minus 1, OH minus 1 to get 0. Now, I want to point out that this is the most common mistake of students, is they do not put this OH in parentheses. So this has to be FeOH3. We have 3 hydroxides. Now, what students do is they do FeOH3. Well, what's the difference? First of all, we don't know it's hydroxide. This has 3 hydrogens and 1 oxygen. This has 3 oxygen and 3 hydrogens. So be sure to put parentheses in for that. So we'll do a few more here, and then I want to point out a few things. So number 7, iron 2 oxalate, Fe plus 2, oxalate C2O4, negative 2. So no parentheses. Okay, let's look at a couple of weird ones. And let's go down to number 22. 22 has mercury 1. So you would think that mercury 1, well, that's simple enough. Mercury 1 is simply Hg plus 1, because Hg is mercury. Bisulfide, if we look it up on our pink sheet, bisulfide, Hs minus 1. So that would give us Hs minus 1, and we're done. But that's not the case. Mercury 1's freakish 1. Mercury 1, I want to point out, is similar to peroxide. So here's where I want to take a time out here and explain a couple things. So, Mercury 1 and peroxide on this side. So mercury 1 is Hg2 plus 2 on our pink sheet, and peroxide is O2 negative 2. Well, what it really turns out is there's actually 2 mercury 1s hooked together all the time. To be more stable, 2 of them are hooked together. So if each mercury of this is mercury 1 and there's 2 of them, we get a plus 2 charge. Similar to peroxide. There is 2 oxides together, but each oxide is a negative 1, so it makes sense that overall this is Hg with a 2 always there, plus 2, and peroxide is O2 negative 2. And that also explains why there's an O negative 1 here. The negative 1 is the peroxide, and this is a regular oxide, negative 2. Okay, so for this one then, mercury 1 bisulfide is going to be Hg2 plus 2 for the mercury 1. Bisulfide is Hs negative 1, and we're going to need another. So this becomes Hg2 Hs2. Okay, so where's a peroxide? Right here, number 10 is a peroxide. So here's barium peroxide, Ba plus 2, O2 negative 2 for the peroxide. So that is done. And 21 is a regular mercury. So this is Hg plus 2, hypochlorite ClO negative 1. So we would need another ClO negative 1. This is another one where students do not put parentheses around it, but hypochlorite ClO2. Okay, there's one more thing I want to point out to you. On this pink sheet here that I'm going to put on the screen, if you start looking at these acetates and aluminate and everything, almost all of these are negative except for this one, ammonium. Ammonium is a polyatomic positive ion, and mercury 1 is another one that's considered polyatomic positive, even though it's 2 of the same hooked together. And then these last ones here are positive. I really don't use these. Otherwise, your polyatomic ions here, negative, 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 negative. You see all these negatives. Okay, so ammonium, I don't know if I have one on here with ammonium. Oh yeah, here's number 30. Let's do number 30 on the next page. Ammonium sulfide. So ammonium is NH4, sulfide S negative 2, so we would need another ammonium. So in this case, we're going to have a parentheses around the positive. So we would have NH4 2 S. Okay, that's how to write out these formulas of compounds. Again, only use parentheses if you need to, so complete this, everything through page 4, and we'll talk to you for the next recording.